Day. So today, this is our second session on hyperbola. In our first session, we had discussed a number of concepts and definitions related to hyperbola, and we tried to understand them through problems. Actually, this is a two-way process. When you have a good understanding of concepts, basic concepts, you are able to solve the problems. And when you solve the problems, you strengthen your concepts. And when you find a difficulty there, that refines your concepts basically. So today, in our second session, I start from where we stopped last time. You can see that in we were talking about the equation of a tangent. If you are given a hyperbola, any hyperbola, this is a standard form, x square upon a square minus y square upon b square is equal to 1. And if you have a point lying on the hyperbola, you can write the equation. If you are given the coordinates are x1, y1, and this is the equation x square upon a square minus y square upon b square equal to 1. Then the equation of the hyperbola is x1 upon a square minus y1 upon b square. We also represent it by t is equal to 0. T is equal to 0 is the expression x1 upon a square minus y1 upon b square minus 1. Is that okay? Let's see. Now we find the equation of normal to the hyperbola. This is the equation. I hope I told you. This can be expressed in various forms. For example, I have written here a square x upon x1 plus b square y upon y1 is equal to a square plus b square. I could have written it as x upon x1 upon a square plus y upon y1 upon b square equal to a square plus b square. You can see they are just equivalent. In some of the books, you will find that they are writing this equation first and then deriving. And what is the relationship between a tangent and a normal? They are always perpendicular. So given any curve, I told you, if this is a tangent at this point, a line perpendicular to this will be the normal to the curve. Please, let's see more. Then I told you that if you have a parametric equation of hyperbola, what is that? X is equal to a secant theta and y is equal to b tan theta, and this theta varies. Whenever you take different values of theta, you get different points on the hyperbola. Similarly, do you know what is the equation for ellipse, parametric equation? Because ultimately when you come to solving problems, it is not necessary that a problem will involve only hyperbola. So the equation there is x is equal to a cos theta and y is equal to b sin theta, and you can very well see that when you substitute it here, y square upon b square equal to 1, this is satisfied. That again means whatever be the value of theta, this point will always satisfy the equation of the ellipse given in this standard form. Similarly, you can see that if there is a circle x square plus y square upon a square, the equation is x is equal to a cos theta and y is equal to a sin theta. You can notice this. If a and b are different, then it becomes an ellipse, otherwise it is circle. Similarly, what about a parabola? What is the parametric equation? X is equal to at square, y is equal to 2at. This is for the parabola, y square is equal to 4ax, and you can see whatever may be the value of t, this equation is satisfied when we take x is at square and y is equal to 2at. And parametric equation is always helpful. Like you can see, this I've already told you that whenever you are given any theta, hyperbola x square upon a square minus y square upon b square is equal to 1 is given. This parametric form, that means x is equal to a secant theta and y is equal to b tan theta, always satisfies the equation of this hyperbola. Let us see what is the equation of tangent in this form. This becomes the equation of tangent. I hope that is clear, because had the point been x1 y1, you could have written xx1 upon a square minus y1 upon b square equal to 1. For x1, if you substitute a secant theta, and for y1 you substitute b tan theta, this equation will be obtained. Okay, and this is the equation of normal. Can we obtain it? Have you done it? How to obtain the equation? It's very simple, although the proofs will not be required for our purpose, but because it is a very simple thing, you must see. You have seen that xx1, that means upon a square minus y1 upon b square, this is the tangent, and when you are substituting a secant theta and b tan theta upon a square upon b square equal to 1. So the equation is what? X secant theta upon a minus y tan theta upon b equal to 1. If you are given this equation, can you write the equation of a line which is perpendicular to this and passes through this point? What is the point? A secant theta, b tan theta. Can you do that? This is pretty simple. You have first to find the slope of this tangent. What is the slope? You have to write it in the form y tan theta upon b is equal to x secant theta upon a minus 1. I have shifted y tan theta to that side and brought 1 here, and from here you can see y is b divided by tan theta x secant theta, and this a is there, minus, I'm not for the time being interested in this quantity, whatever it comes out to be, because I am interested in the slope. What is the slope of tangent therefore? It is bx upon a, b upon a, this x is not required, and what is there? Secant theta over tan theta. But you can see if I write sin theta, tan theta as sin theta upon cos theta, this will become b by a sin theta. That will be the expression. This is slope of tangent. So what will be the slope of normal? Slope of normal is therefore minus a upon b sin theta. Now given this point and given this slope, you can write this equation. I need not do all the calculations. Y minus b tan theta is equal to the slope of the normal into x minus a secant theta. If you solve it, you will get this form: ax cos theta plus by cot theta equal to 1. This will be the final result you will be getting. I was just giving you the calculation so that you know how to do it. The purpose is not to solve it here. Okay, let's see. And this is the condition of tangency. When is a given line tangential to a given curve? Let us concentrate only on hyperbola. If you have a hyperbola like this, I'm drawing just one branch of it, and a given line. It will be tangential only when it meets it at one point. But we know that every equation, every line can be represented by the equation y is equal to mx plus c. So what we do is, if we try to find out the point of intersection of a tangent, a line and a hyperbola, how many points we'll get? It depends on whether it is a tangent or not. But the general technique is finding out the intersection of a line and a given curve involves two things. First of all, for example, here x square upon a square minus y square upon b square equal to 1 is given, and this line is given. First thing is, let me substitute the value of y here, because I want to know the points where this line and this curve meet. It will be x square upon a square minus mx plus c whole square upon b square is equal to 1. You can see that this is a second degree equation in x. You have values of x, second degree terms of x, x square. From here you will get m square x square plus c square plus 2mcx. So you will have terms containing x square, terms containing x, and terms containing the constant term. So there is a quadratic equation in x. How many roots does a quadratic equation have? Two roots. They may be coincident also. If the two roots are different, you will get 2 points. That means the line and the hyperbola will meet in 2 points. It's possible that the roots are imaginary. That means the line and the hyperbola never meet. And it is quite possible that you have two coincident roots. Then it means when you are trying to solve this equation, its discriminant must be 0. So what you have to do now, this is your homework. Go home, simplify this equation, find out the coefficient of x square, find out the coefficient of x and the constant term, and see for what values b square minus 4ac is 0. Discriminant is 0, and you will obtain this equation. This relationship c square is equal to a square m square minus b square, or for that matter, you can also write it as c is equal to a m square minus b square under root plus minus. So whether c is equal to square root of this or negative of square root of this will always be a tangential. That means when you are given a line of the form y is equal to mx plus c, you can read m from there, you can read c from there, and you are given the equation of a hyperbola, you can read a from there, b from there, and see if this equation is satisfied, this relationship is satisfied, then it will be tangential. Is that okay? The proof part, let us see some problems on this now. Just let me see the last slide. Therefore, since we have seen that if a line y is equal to mx plus c is tangential to a given hyperbola, the value of c must be this. So therefore, the line y is equal to mx plus c can be written as this: y is equal to mx plus, this is our c, but it can be under root of a square m square minus b with a positive sign or with a negative sign. Is that okay? That means given a hyperbola and a straight line, the only thing you have to see is whether c is satisfying this relationship in order to check whether it is tangent or not, or in order to write the equation, this is there. What it means is whatever may be the value of m, you put m is equal to 1, you will get a straight line if you write this equation. You take m is equal to 2, you will get another straight line which is a tangential to, which is a tangent to the given hyperbola. So for every value of m, this line and this line, they represent a tangent to the given hyperbola x square upon a square minus y square upon b square equal to 1. I hope my point is well taken. Let's go to a problem now. This is a very straightforward problem. You are given the hyperbola, you are given a point, and we have to find the equation of a tangent. So what we have to do is, we replace 1x by 5, 1y by 16 by 3, and try to see what is the equation, which choice is correct. Can you say? Find out. It is which one? A. Okay. Let's see the answer. Just click. Push C. Because one of the x has to be replaced by 5 upon 9. One of the y's has to be replaced by 16 by 3 upon 16 equal to 1. So it becomes 5x by 9 minus y by 3 is equal to 1. If we take LCM, we get 5x minus 3y equal to 9, which is the choice A. It's very simple. Let's go to the next problem. Equation of normal. Again, just try. You have the formula. What was that? A square x upon x1 b square y upon y1 equals to 1. So now in this question, you have to write a square. What is a square? Okay, yes, this is plus. So a square x, here a is given to be, in our case, a square is 16, b square is 9. So a square x means 16x upon x1. x1 is given to be minus 4. What about 0? We substitute here. Instead of y, we are going to have 0. So whatever we have here is meaningless now. B square was 9. Okay, let me substitute. It is 9 into y divided by y1. Oh, let's not, because you will have some problem here. Normally, we do not divide by 0. But here it is just a symbol. What it means is, we could have written our formula in a different way. I'll let you know. But suppose I write it like 9y is equal to 1 minus something. We are getting some expression here, and this is 0. So this is just symbolic. It means it is to be multiplied by 0, and you get y is equal to 0. You could have written your equation in such a form that this y does not occur, y1 does not occur in the denominator. For example, I could have written it like this. Before attempting this problem, I could have written as a square x y1 plus b square y into x1 is equal to x1 y1. We could have used this so that we do not have a problem substituting 0. So now you can see that the equation will come out to be y is equal to 0, which is x. By the way, where is point minus 4, 0? Okay, let me ask you whether it is lying on this hyperbola. That means somewhere here the point will be x is minus 4. X is minus 4, so somewhere here. What is the, this is the point actually. Minus 4, 0. What are the vertices of this particular hyperbola? How do you find vertices? That means those points where this hyperbola intersects with x-axis. How to do that? Put y is equal to 0. If I put y is equal to 0 in this equation, x square upon 16 minus y square upon 9. I'm now telling you a better way of doing this problem. I told you that sometimes graphs help us a lot. Instead of doing any calculation, this hyperbola was something like this. This point is minus 40 and this point is 40. How do we know that? Because a is 4. And the point where you are interested in finding out a normal is minus 40, this point. So do you think we at all have to do anything? Because tangent is here. So tangent is, so normal is this. Directly we can say it's x-axis. So in fact, we do not have to do any calculation for this purpose. Just having realized the picture of this particular hyperbola, we could have just guessed that y is equal to 0 is the answer. And what is the equation of tangent, by the way, now? X is equal to minus 4. Because this point is minus 4 and the tangent is parallel to y-axis, it must be x is equal to minus 4. So I would always advise you, whenever you are practicing some questions, you just see whether you can do it without doing any calculations. Maybe that there is a very simple technique, visualizing the graph and writing. Okay, we go to the next one. Equation of the tangent parallel to a particular line. Here, what is happening? We are given a hyperbola x square by 9 minus y square by 4 equal to 1 by 36. And you have to find out a tangent. We are not given the point. We are given another straight line to which it must be parallel. You can see this picture. Suppose this is the hyperbola and here is a straight line. We have to find a line which is parallel to this, somewhere here, which is tangential to the hyperbola. You can have a number of lines which are parallel to this given line. This is your given line. Y is equal to 5x plus 5. If I rewrite the equation, minus 5x plus 4y equal to 5, it will become y is equal to 5x by 4 plus 5 by 4. This is a given line. There are a number of lines. How many lines parallel to this line? Infinite. Out of them, which is the line which is tangential to the given hyperbola? That means it meets the hyperbola at just one point. So what we have to do is, we have to find the slope of this. What is the slope of the given line? M is equal to 5 by 4. Now, you know the slope form of tangent. What was that? Y is equal to mx plus a square m square minus b square. A is given. A square is 9. This, no, you have to be careful writing a and b. What is a? What is b? A is, no, A is not 3. You will commit a mistake. Yes, because you write x square by 9 minus y square by 4. You must have 1 here. So you have to multiply this by 36 and this by 36. So this becomes 4x square minus 9y square equal to 1. So you can write it x square upon 1 by 4 minus y square upon 1 by 9 equal to 1. So when you are trying to find a and b, from the standard equation of hyperbola, make sure that on the right hand side you have 1. So now a square is 1 by 4, b square is 1 by 9. Substitute in this. M is 5 by 4. Y is equal to 5 by 4 times x plus under root of a square, which is 1 by 4, into m square, which is 25 by 16, minus b square, which is 1 by 9. And if we simplify this, what do we get? We have the denominator as 64 by 9 and 225 here minus 64 into 9. 64. When you subtract, you get 161 divided by 64 into 9. I have intentionally not multiplied 64 and 9 because ultimately we have to take the square root and both of them are perfect squares. So it is going to be 24 here, 8 into 3, and you have 161. And now you can choose. So equation is y is equal to 5 by 4x plus, I should have written, I'm just simplified this. So it is this divided by 161 upon 24. That means 24y plus minus 30x is equal to root 161. B is the choice. I had intentionally taken 1 by 36 here so that you be careful. Okay, let us see the next question. This is just similar. I hope you can do it. In this case, x square upon 3 is there and y square upon 2 is there. So a square and b square are directly known to you. M is also known to you. M is 3. You will substitute and you will get the result. I leave this question for you. Next question, please. Oh, now, okay. Please, let's go back to the last question. In this, I think that you do this question. Let's do this question. I've chosen this question intentionally. The hyperbola is x square by 3 minus y square by 2 equal to 1. So a square is 3, b square is 2, and the line is y is equal to 3x plus 4. Therefore, the slope is 3, and the equation of the line will be y is equal to mx, 3x plus minus. It can be plus, it can be minus. What is inside? A square into m square minus 2. So it is 3x plus minus root 25. So you are getting two equations, 3x plus 5, 3x. Normally such a problem will not be there when two choices are true. Instead of D there, we should have written D and B. But even with two choices, the question can be framed. The choices could be this and this, this and this. They can give both the choices in one. So when will you take the answer? When both the choices are correct. Number one. Number two, now we see the next question. The same hyperbola I have taken, 2x square minus 3y square is equal to 6. And I'm asking, out of the two tangents of this hyperbola, which are parallel to the line 3x plus 4y is equal to 3x plus 4, which one is parallel? Oh, which one is there a typo here, a typing mistake? Which one is a tangent to the branch lying on the right hand side of y-axis? There are two branches of the hyperbola. One is on the right of y-axis, the other in the left of y-axis. So I am asking, out of these two, which one is on the right hand side of y-axis? Let us see. Can you tell me what are the equations? These are the two equations. And there are two branches of the hyperbola. One somewhere here and one somewhere here. Where does this particular line y is equal to 3x plus 5 lie? For x is equal to 0, what will be y? For x is 0, y is 5. And what about when we take y is equal to minus 5 by 3? Somewhere y is 0, and when y is 0, x is minus 5 by 3, somewhere here. So you are having, let me draw it like this, something like this is happening. Otherwise also, without doing anything, if we check the x and y for both of them, I mean, what are the points where this line meets on the x-axis and on the y-axis, you can draw the line. And that will tell you, because it is intersecting this, it won't be tangential to this. So this way you can check out. Is that okay? In some problems, this may happen that one of the line is this and the other line is this. So whatever the line is, whatever be its equation, we can always check which particular branch of the hyperbola it will meet tangentially. You can do it by drawing. This was a question that developed only because we were getting two values there. So I just thought you should know this also. Will you be able to try such problems? Let's see the next problem. Any doubts about this? Okay. Now this is again a problem on the tangent to hyperbola. Now you are given a line y is equal to mx plus 6 and a hyperbola. You have to find the value of m. This must be simple. Let us apply the condition of tangency. If this line has to be tangential to this hyperbola, x square upon 100 minus y square upon 49 is equal to 1. So a square is 100, b square is 49, and c is 6. M is to be obtained. This is pretty simple now, because the relationship is known to us. It is a square, m square minus b square. There are four quantities involved. Whatever three you are given, you can find out the fourth. In this case, the three things given are C, A, and B, and you can check up. Probably the answer is, what is that? Check up. Answer is A. Such techniques are usually employed by the paper setters. You can see all the answers are differing from each other very minutely. they are appearing to be the same. I mean, somebody may get confused upon between this and this. This is root 17 divided by 20. It is 17 divided by 20 and then the square root of the whole. Okay, let's see. Go to the next question. Now it is finding out the point of contact. That means you are given a line. It is given that it is a tangent. And you have to find out the point at which it is tangent. So what is missing is the point. That means hyperbola is given, line is given. This point is not known. By the way, अगर आप एक तरीका तो ये है कि आप चेक कर लें इनमें से कौन सा पॉइंट लाई ही नहीं करता हाइपरबोला पर. अगर एक ही पॉइंट हाइपरबोला पर लाई करता है तो वही पॉइंट इसका पॉइंट ऑफ कांटेक्ट होगा. बट दैट आल्सो इज इन्वॉल्विंग आई. आपको 4 पॉइंट चेक करने पड़ेंगे. तो आप एक काम क्या कर सकते हैं, इसका इंटरसेक्शन निकाल सकते हैं दोनों. जब दोनों का इंटरसेक्शन निकालेंगे तो आपको पॉइंट मिल जाएगा. कैन यू सॉल्व दिस इक्वेशन? Let's try. Please try whether you can solve it or not. What do you get? 3x square minus 4 into x square plus 1 minus 2x equal to 12. 3x square minus 4x square minus x square plus 8x minus 12 is equal to 0, or x square minus 8x plus 12 equal to 0. Solve it. What is the value of x you get? Could you get it? Should I do it or wait? It's minus 6. Okay. Well, then it's pretty simple, because then it is x minus 4 whole square. That means x is equal to 4. So immediately those choices are ruled out where x is not 4. If there is only one choice containing x equal to 4, immediately take it that. Otherwise, you know, so the point is 4, 3. The choice is B. Is that okay? So you always have to find out the easiest method with the which you can. Let's go to the next question now. Oh, this is a bit tricky. Can anybody tell me how to proceed? Okay. There are few things we should know. Here even the hyperbola is not clear. It says that A is a parameter. That means A can vary. That means you can have something like x square minus y square equal to 1. You can have x square minus y square equal to 4. You can have x square minus y square equal to 9. These are different hyperbolas because A is not a constant here. And you can see, suppose I draw only the right hand side branch of the hyperbola. This will pass through 1, 0, 1, 0. The hyperbola will be like this. This will be passing through 2, 0. I mean, the width also will change because the width depends on what? It is lattice rectum. What is lattice rectum? 2b square upon A. So as A will change, the parabola will shift to its right and it will its lattice rectum will become smaller and smaller as you increase A. You can see that this way. Maybe that if you take A to be very large, 100, it will have a very small lattice rectum. Now, let us try to understand. It says there is a line now, y is equal to 2x. If I want to draw it precisely, I do it again because y is equal to 2x has to pass through origin. Let's try to have a clear picture of this. This is nearly y is equal to 2x. Because I know that the slope will be 2, I have not taken a line bisecting the quadrant because its slope will be 1. It has to have slope 2. So I have drawn it like this. It passes through it. Now I take any one of the hyperbolas. Now can you guess which is the point nearest? So suppose you find if this is the nearest point, you can observe that the tangent to this hyperbola at this point will be parallel. Now to pick up any other point, what is the distance between hyperbola and straight line? Now this. If you take this distance is increasing. So you draw all such lines. What I'm trying to do is, I'm trying to draw perpendiculars to the line from points on the hyperbola. Take any point of the hyperbola, draw a perpendicular. Take another point, draw a perpendicular. Out of these, the one which is nearest will be the point where the tangent to the hyperbola is parallel to this. Because now this particular line segment will be perpendicular to this as well as to the tangent. And this holds for every A. Whatever be the value of A, for one A you are getting one hyperbola. For another A, another hyperbola. Whatever be the hyperbola, the logic now is that the point nearest will be the one which is a tangent to this and parallel to this. Let us use this. So this becomes a problem of the type we have already done. What is the slope of this hyperbola? 2. Sorry, slope of this straight line? 2. And suppose I take a point HK on the hyperbola. Take a point HK on the hyperbola. Then HK will satisfy H square minus K square equal to A square. What is the equation of tangent at this particular point? Equation of tangent to x square minus y square equal to A square at the point HK. It is xh minus yk equal to A square. That's how you do xx1 minus 5y1. What is its slope? slope is calculated in the following way. Yk is equal to xh minus a square. So y is equal to h by k into x minus a square by k. So the slope is this. Slope is h by k, and this must be equal to 2. Why? Because we have observed if this point is to be the closest, then the tangent to the hyperbola at this particular point must be parallel to the line y is equal to 2x, and this gives me h is equal to 2k. So therefore you can guess from here y is x is equal to 2y is a locus. This is how we find locus. We take a point h k and then ultimately convert it to x and y. That means any point that satisfies this condition must be closest. So it is y is equal to x. If you have seen the calculations and understood them, I would like to just elaborate one more point on this. The last. Is that okay? Let us see one more thing about this. You can see that here the line was fixed. A line was fixed. Y is equal to 2x. Hyperbolas were changing. It may be of this type. It may be this. It may be this. It may be this. But the question actually was, for every hyperbola, you find the nearest point. For it may be somewhere here. For it may be somewhere here. Find all of them and join them. What you will get? That was the locus. कि एक एक हाइपरबोला पर जो जो पॉइंट आपको इसके नियरेस्ट मिल रहा है उन सबको मिलाने से क्या मिलेगा. ये स्ट्रेट लाइन और कैसी है? x is equal to 2y. x is equal to 2y. ये मैंने बिल्कुल डायमेंशंस में नहीं ड्रॉ किया है. एक्चुअली आप देखेंगे तो लाइन की पोजीशन कुछ हो रहा है. But this is the concept behind it. It was a pretty good question. It gives you a lot of ideas how to think. Now let's go to next question. These we have to skip because I wanted some animation to run through, but the software that is required is not there. Okay, leave this also. I could have shown you animated hyperbolas. They are actually moving as A moves. Their latest spectrum starts decreasing and vertex starts shifting to the right. Now the question is, how many tangents can be drawn to a hyperbola from a point? This is to be understood. You can see, if the point lies here, there will be only one tangent. If the point is inside, you cannot have any tangent. Any line passing through this will meet the hyperbola. It will intersect, but not tangentially. What about this point? This point is outside the hyperbola. So you can draw a tangent like this. There are two tangents. So what I have jotted down here, a point P is given to you, hyperbola H is given to you. If P lies on H, the tangent will be unique. If P lies outside H, there will be two tangents. And if P lies inside H, the tangent will not be there. The line, any line passing through that will not, no line passing through that particular point can be a tangent to the given hyperbola. You can have direct questions on this also. Please let us see. You want to note it down? Please do. Please show the last slide. Let's go to the next one. It says, there is a question probably. No, Asha, this is the equation. Before coming to equation of the pair of tangents, we must know one thing. How will we decide that a given point is inside the hyperbola, on the hyperbola, or outside the hyperbola? So this is the technique. You find out this expression S1. What is S1? Substitute x by x1, y by y1. So this expression, x1 square upon a square minus y1 square upon b square minus 1. This is always denoted by S1. And if this S1 is greater than 0, the point will be inside the hyperbola. If it is less than 0, the point will be outside the hyperbola. And if it is equal to 0, the point will be on the hyperbola. So you can always decide. So if you are asked a question, a hyperbola is given, a point is given, and you are asked how many points are there, how many tangents from this particular point can be drawn on the hyperbola. Then you will first check whether the point lies inside, outside, or on. If it is inside, 0 tangent. If it is on the hyperbola, there is 1 tangent. And if, okay, probably there will be a question of this type. Let us see the next question. Okay, here is how we write the equation. I told you that given this and S and S1 and T, we can write the equation as SS1 equal to T square. What it means? S1 equal to T square. This is representing the pair of equations, pair of tangents. Because each line, each tangent is a line, the joint equation is given by a second degree equation, which is known as a pair of straight lines. Please show me this is the equation. SS1 is equal to T square. Mind it, the point is outside. Pair of tangents from a point x1, y1, which is lying outside the hyperbola. The equation is given by SS1 equal to T square, where we now very well know what is S. This is S, this is S1, and this is T, the equation of tangent to have. I mean, expression derived from there. So this is the complete equation. So you can do problems if you are given a point and a hyperbola, and you are asked to give the equation of pair of tangents. You can always do that. I write for you. Should I write it here? So now you just note down this expression. This is sufficient. SS1 is equal to T square. You know what is S, what is S1, what is T square. Let's move to the next slide. We have a lot to do. Now, when this point P is outside and we are getting 2 tangents and we are getting 2 points of contact, this and this, I could have marked them A and B. If I join them, I get the chord of contact. There are a number of chords in the hyperbola. The one which is joining the 2 points of contacts of this pair of tangents is known as the chord of contact, and its equation is given by T is equal to 0. Now this may be sometimes confusing. Why? Because T is equal to 0 also represents the tangent, and t is equal to 0 is also representing the chord of contact. But as such, there is no contradiction between the two things. You can see that. Now I draw two figures. If there is a point here and you draw a tangent, the equation is t is equal to 0. But the condition is that x1, y1 lies on the hyperbola. Now in this case, point x1, y1 is outside the hyperbola. So there are two tangents and line joining them is the chord of contact, t is equal to 0. What happens if these 2 points come closer? Suppose what happens if this point comes here, x1, y1? You can see that something like this is there. This is the chord of contact. If you take it here, something like this will happen. This is the chord of contact. So you can see as the point is coming nearer and near to hyperbola, this chord of contact is ultimately becoming a tangent. Suppose the point was here, the tangent will be somewhere here, the pair of tangents, and the line will be like this. And when this point lies exactly on the hyperbola, it becomes a tangent. So as such, there is no contradiction. The only point to be you have to keep in mind is that here in this case, where you are talking of this tangent at a point, that point lies on the hyperbola. Here, in case of pair of tangents or chord of contact, the point is outside the hyperbola. But the two concepts are not contradicting each other. Ultimately, the chord tends to become a tangent if the point approaches the hyperbola. The equation is clear. T is equal to 0 means x1 upon a square minus y1 upon b square minus 1 is equal to 0, or you can say it's equal to 1. Please, let's proceed. This is simple now. You are given a hyperbola 6x square minus 9y square equal to 144, and given a point 2 minus 1 equal to 0. We have to find the equation of chord of contact. So what we have to do? (16x square minus 9y square) 16x into x1 minus 9y into y1 is equal to 144. We don't need to do that even. You can do it directly, because ultimately what you have to do is replace x by x1, x square by x1, and y square by y1. So that calculation is not required here, because you don't have to choose what is a and what is b. So you can do it directly. So what is x1 here? 2 minus 1. 32x plus 9y. I mean, you are thinking in the right direction when you say that let's convert the right hand side to 1. But what will you do? You will convert that. What will happen? X square divided by 9 minus y square divided by 16 equal to 144. Equal to 1. Now you will substitute x and x1. Then in order to obtain the results that are given there, so now there is one thing you should note down. You must always Look at the choices that are given. Had the choices been like this, then you should have converted. If the choices are not like this, they are of this form, to do it directly. I mean, that's we are trying to save every bit of time, every second there. Otherwise, both the methods will be okay. So far as equation of tangent is concerned, even if you are given a hyperbola in this form, suppose x square, suppose this is the equation. I know this is a hyperbola. Why? Because it is second degree equation and the coefficient of x square is not has the opposite sign from that of the coefficient of y square. अगर इस पे टेंजेंट लिखना हो x1 y1 पॉइंट पर तो क्या होगा x1 minus 2y1 3x plus x1 because 6x means you have to 3 into 2x plus 7 by 2 so we need not in order to write the equation of tangent, no conversion of that type is needed. Otherwise, this also you have to write in near standard form. Okay, let's see the equation. Now this is pretty simple. It is direct result. D is the choice because you are asked how many tangents can be drawn to a hyperbola passing through a given point P. It depends on the position of the point with respect to the hyperbola. Let's go to the next question. This was a very direct question. If you know the result, you can answer it quickly. One of the techniques in the examination would be, if you can do a question very quickly, do that. If you are stuck up, leave that, go to the next question, and you can come back if you are left with some time. The number of tangents from the point this to the hyperbola. So you have to check whether the point lies inside, outside, or what. So here, I hope you will do that. What is S? 3x square. Sorry, S1 is 3x square minus 5y square minus 1. And at this point, at the point 2, 3, it is 3 into 4 minus 5 into 9 minus 1. This is going to be negative. Negative में क्या होता है? Sure. Check the result. Show them the result. Just go to last slides. Again. Please, back, a bit back. Go back, please. When S1 is less than 0, it is outside. So therefore, there will be two tangents. Okay, let's continue. Let's go to the next question. This is something good. I told you that you will many times get questions which combine, say, parabola with ellipse, or with hyperbola, or hyperbola with straight line, and so on. Here there is a question which involves a circle and a hyperbola. And the question is whether this given circle x square plus y square is equal to a square and this given hyperbola x square upon a square minus y upon b square meet at all or not. And if they meet, in how many points do they meet? One thing is clear, if you substitute the value of y square from one of the equations into the other and solve, you will get a quadratic equation in x and you will get. But you are not supposed to do that. Graphical representation of the graphs is known to you, of these curves. Where is the hyperbola? Somewhere here. A0 and minus A0. Because its equation is x square upon a square minus y square upon b square equal to 1. And what is the circle? X square plus y square is equal to a square. All of you know this is a circle centered at 0, 0, having radius a. So if a circle has center at this point and radius is a, it will be something like this. Don't have to do anything. Just if you can visualize, you'll get the result. In how many points are they meeting? 2. And suppose the radius is more than a, center is here only, you will get a circle like this. 4 points. Can you imagine a circle which meets at 3 points? Let's see. What kind of? Yes. Suppose I have a circle centered at this point, not at origin, and I take this much as the radius. What will happen now? It will meet here and the points of intersection are 1, 2 and 3. You can have a circle and a hyperbola meeting at 2 points, 1 point, 4 point, 3 points, 1 point. 1 point भी हो जाएगा. How? This is one branch, this is another branch. Take a circle जिसका center a by 2 हो, center a by 2 for example, और radius भी a by 2. ये सिर्फ एक पॉइंट पे मीट कर रहा है. ऐसा सर्कल भी हो सकता है जो मीट ही ना करे. यू कैन हैव ड्रॉ अ सर्कल हियर, ड्रॉ अ सर्कल हियर. चलिए नेक्स्ट क्वेश्चन देखते हैं. यू हैव ऑलरेडी डन दिस. x स्क्वायर प्लस y स्क्वायर इज इक्वल टू 4a. एक्चुअली प्रॉब्लम क्या है कि वहां फिगर नहीं होगी ना. यू हैव टू गेस इट फ्रॉम द इक्वेशंस. x square plus y square is equal to 4a square is a circle whose center is 0, 0 and radius is 2a. So when, okay, four points, because this is the center, this is 0, 0 and 2a means somewhere here. It will be meeting at 1 point, 2 point, 3 point and 4 points. Similar things can occur with other curves. Let's see the next question. Oh, I want you to frame questions. One method of knowing everything about a subject is, once you find a question, try to make similar questions. Let's try to make some questions based on this concept. We have just constructed some questions right now. Suppose I want to take this concept that you will be given equation of a circle, equation of a hyperbola. It meets in only one point. ये पॉइंट क्या है? A zero. ये पॉइंट क्या है? 0 0. और ये क्या है? A/2 0. और रेडियस कितनी है? तो इसकी इक्वेशन लिख सकते हैं x माइनस A/2 होल स्क्वायर y माइनस, तो आपने क्वेश्चन बना दिया. अब क्वेश्चन क्या बनेगा? इन हाउ मेनी पॉइंट्स डज दिस सर्कल मीट द हाइपरबोला? Is it okay? So you could construct at least 10 questions based on this. You can do it. Okay. We come to this next concept, which is very important, which I mentioned in the first lecture, but did not explain properly. That is the concept of asymptotes. And asymptote is a line which we say in layman's language that it touches the curve at infinity. If this is a line and this is a curve, you can see that as we move on the curve, the distance of this point from the curve goes on decreasing. This is called an asymptote. Okay. You have seen the graph of y is equal to 10x. It is like this. Tangent x is 0 at 0. At pi/2 it is infinity. At minus pi/2 is also going to infinity, but it is minus infinity there. So this line is an asymptote. What is its equation? Its equation is x is equal to minus pi/2. Its equation is x is equal to pi/2. This is 0. You know that at pi/4 it has got value 1. The values you can find out. But it goes on increasing. But as you approach pi/2, it goes to plus infinity. As x or theta approaches 0, it goes to minus. These are asymptotes of the tangent. It has got a number of asymptotes. This particular branch has got two asymptotes. Similarly, a hyperbola will have two asymptotes like this. So this is one asymptote. This is a second asymptote. Let's see the diagram. You know that the hyperbola x square minus upon a square minus y square upon b square is equal to 1 passes through this point, the vertex, and this point. This is the origin or the center of the hyperbola. If I draw this line and this line, these are the two asymptotes, and their equations are very simple. If instead of this one I write 0, I will get the equation. Because you can factorize it into two parts, x upon a plus y upon b is equal to 0, and x upon a minus y upon b equal to 0. Let us see. This is the hyperbola x square upon a square minus y. Asymptotes are given by that means you factorize, you get x upon a plus y upon b into x upon a minus y upon b. So the two asymptotes are x upon a plus y upon b equal to 0. These are the two equations. And out of these two, which one is represented by x by a minus y upon b? You can see, because this line will have slope positive. When you shift y to that side, y becomes b upon a into x. That means the slope is b upon a, and we are taking ba to be positive, both of them. So this has got positive slope, this has got negative slope. So a question may be, which one of the two asymptotes lies in the first and the third quadrant? This is the first and third. And the second one, x upon a plus y upon b is equal to 0. It passes through the second and the fourth quadrant. Its slope is negative. That's perfectly fine. Let's see. Straight from here, I come to conjugate hyperbola. Let us see. By now we know pretty well that, let me also draw the asymptotes. It's always nice if you draw the asymptotes first. That's one way of drawing a hyperbola. See what is a, so the point is known to you, a0 minus a0, b minus b, and draw a rectangle like this. This point is a0, this point is minus a. Now you have to draw a hyperbola. It's simpler to draw. Something like this. Because I know it is to be tangential at this point and this point, and it is to be asymptotic, I say. It is an asymptote, so we say that the curve goes asymptotically towards this particular line. This is our original hyperbola. What is its equation? So this hyperbola, this is the conjugate hyperbola with respect to this hyperbola, the given hyperbola. What is the difference? The transverse axis of the original hyperbola is the conjugate axis of this hyperbola. And the conjugate axis of the original hyperbola is the transverse axis of the new hyperbola. Now suppose I rub off the old one. Let me just rub it off. Now you see this hyperbola in new light. What kind of a hyperbola is this? There is y-axis, there is x-axis, and the hyperbola goes like this. Naturally, y-axis is its transverse axis and x-axis is conjugate axis. It is just opposite to that of the original hyperbola. So the equations, you can see this equation was the original equation and its conjugate minus x square upon a square plus y square upon b is equal to 0. Why? Let us see this. Minus x square upon a square plus y square upon b square equal to 1. If I want to know at what points does it meet x-axis, what I will have to do, I'll have to put y equal to 0. If I put y equal to 0 in this, I get minus x square upon a square is 1. That means x square is equal to minus a square. It does not give me any values of real values of x. That means this curve is not meeting x-axis. Whereas if I put x is equal to 0, I get in this, if I put x is equal to 0, what do we get? Y square upon b square is equal to 1. This means y can be b, it can be minus b. That means it is meeting the y-axis at 2 points, b and minus b. Therefore, the transverse axis is along x-axis. So therefore, its equation can be written like this. Just a negative sign here. As such, this is an independent hyperbola because we had taken this hyperbola originally and we are looking at this hyperbola in context of this hyperbola h. We call it the conjugate hyperbola of this. Both the hyperbolas are conjugate of each other that way. Okay, let's see some more things about this. One thing you can note is the last slide. Both the hyperbola have the same set of asymptotes. We'll come to that. Let's see a problem on this. Oh, this is a problem on asymptotes. Let's see what it says. Asymptotes as such are probably not taught in your 11th class. Have you been taught these things? But the questions are sometimes asked in the engineering examinations. It says product of the lengths of the perpendiculars from any points of the hyperbola to its asymptote of this. For any point. What it means is there are two asymptotes of a hyperbola. We have to find the product of the lengths of the perpendiculars from any point of the hyperbola. Suppose this is the hyperbola. And this is a point on this. Drop a perpendicular. Let me call it P1. Drop a perpendicular. Let me call P2. There are two asymptotes. That means there are two straight lines out in the plane of the hyperbola, and there is a point on the hyperbola. When you drop perpendiculars, you are going to get two lengths, P1 and P2. We have to find out this, the product of the lengths of perpendiculars. Do you know how to find out distance, perpendicular distance of a line from a point, or from a point of a point from a line? In this case, what is given to you? This is the hyperbola. What will be its asymptotes? X square minus y square equal to 0. That means x minus y is equal to 0 and x plus y equal to 0. These are the two asymptotes. Let us take any point on the hyperbola. Suppose x1, y1 is a point on the hyperbola. What will be the distance of x1, y1 from this line? X minus y is equal to 0. How do you find? Replace x by x1, y by y1 divided by x1 square plus y1 square. This is P1. Distance of this point from this line, P1. Now I don't need this. Let us also find P2. X1, Y1 is there. A line is there known as x plus 1 by 0. Perpendicular is P2. So what will be P2? It will be x1 plus y1 divided by, oh, divided by, sorry, divided by root 2. The division is to be done by the coefficient of x square plus the coefficient of y square under root. And here also root 2. Can we multiply these two now? P1 multiplied by P2 gives you x1 minus y1 into x1 plus y1 upon 2. It is x square, x1 square but there is one point we must note. Where had we taken this point x1 y1? It was on the hyperbola. So it must satisfy the equation of the hyperbola. So if I put x1 here and y1 here, I get 8. So this substitute 8 by 2 is 4. So this question involves a little bit of calculation. Still, it is a good question. So you, for this, what you should know, given any hyperbola, how to write its asymptotes separately. Then how to find distance of a point from a line. P1 and P2 we obtained and we multiplied, and therefore we got this result. Answer is A. Let's go to the next question. Now, whatever question you do, try to write 2, 3, 4, as many questions you can write which are similar to the question you are trying. That will increase your insight into the problem. And share it with your friends. Give it to them to solve. And you solve the questions which other friends give you. That will be one way you can improve your ability to solve objective type problems in the examination. Please, let's see. This is for the conjugate hyperbola. I have not written conjugate because in itself it is a hyperbola. When we are writing the two hyperbolas together, we designate it as the conjugate hyperbola of the previous, the original hyperbola. What is the difference now? Here you can see transverse axis becomes y is equal to y axis, conjugate x axis, and what is our 0b and 0 minus b. There they were a0 and minus a0 because they were lying on x axis. Now the vertices will be lying on the y axis. So 0b and 0 minus b. Similarly, directrices. This is one directrix. The length is again y is equal to b by e. Distance from this point to this point is b by e, and from this point to this point is also b by e. So the equations of the directrices become y is equal to b by e and y is equal to minus b by e. We can also determine foci because they will be lying on the y axis now. I have not pointed. It will be somewhere here. 0b will be somewhere here, this red spot, and somewhere here 0 minus b. And the relationship, again a and b, their roles have been reversed. A square is equal to b square into e square minus 1. Is it okay? Shall we proceed? We can try a number of problems on the concepts we have. If we are left with some time, we'll come again to some more problems. See this now, rectangular hyperbola. My target is at least I complete all the relevant concepts, problems we can rectangular hyperbola, if for a given hyperbola A and B are equal, it becomes a rectangular hyperbola. It's called a rectangular hyperbola. The length of the transverse axis and that of the conjugate axis are equal. One thing you can notice from here, that if this happens, what happens to the asymptotes? For example, I'm talking of this hyperbola. Okay, here A and B are normally different. What are the asymptotes? One asymptote is x upon A minus y upon B equal to 0. The other is x upon A plus y upon B equal to 0. Since for a rectangular hyperbola, A and B become equal. So what happens to asymptotes? X minus y is 0 and x, that means y is equal to x and y is equal to minus x. And you can see that these two lines are perpendicular to each other, because the slope of the one line is 1 and that of the other is minus 1. So product of the slopes is minus 1, so they are perpendicular. So this is another property of rectangular hyperbola. Sometimes some books define it like this: a hyperbola is said to be rectangular if its asymptotes are perpendicular to each other. And you can see that this line now exactly passes through y is equal to x. Y is equal to x is the line, one of the asymptotes, and y is equal to minus x. It bisects the second and the fourth quadrant, and they are perpendicular, and the hyperbola is something like this. Now, the box I was drawing will be something like this. Both should be equal. If they are not coming, that means I have not drawn it properly. This length and this length must be equal. Let's proceed. You can see here, I have taken two hyperbolas, H1 and H2. H1 is represented by this solid curve, H2 by this. So they have the same pair of asymptotes. There is no difference. Whether you take this hyperbola or this hyperbola, can you see? They will have the same asymptotes. Why? For this, how do you obtain asymptotes? Making it 0. Here also, make it 0. They are just the same. So the two sets have the same set of asymptotes. This was for the conjugate. I mean, the slide should have come there. And it's nothing to do with the rectangular hyperbola. This is about the conjugate hyperbola. Please, let's proceed. We'll be doing some questions on rectangular hyperbola also. This is a comparison of transverse and conjugate hyperbola. Sorry, normal comparison of a hyperbola and its conjugate. I have tabulated it. For this hyperbola, x-axis is the transverse axis and y-axis is the conjugate axis. For this, y-axis is the transverse axis and this is the conjugate axis. Vertices are plus minus a0, plus minus b0. Directrices, x is equal to plus minus ae, y is equal to plus minus be. The foci, plus minus a is 0, 0 plus minus b. Relationship between AB and Here it is b square is equal to a square into e square minus 1. And here it is a square is equal to b square into e square minus 1. So now we know equation of a hyperbola, equation of a conjugate, its conjugate hyperbola, what is a rectangular hyperbola, okay, and what are its asymptote. We have seen pair of tangents, we have seen chord of contact, and if you know all the results and you have understood them well, you can try a number of problems with them. Let's proceed further and see a few things. This I have already told you. Let's go to the next slide. So we were talking actually about rectangular hyperbola. In between, we shifted to the hyperbola and its conjugate. Now these two are okay. These two are examples of a rectangular hyperbola. You can see that here. How can you say? Because the line given here is y is equal to x, asymptote, and what is the other asymptote? Y is equal to minus x. Although we have in the figure a and b have been written, but from this only we can make out, because the asymptotes are perpendicular, a and b have to be equal. It has to be a rectangular hyperbola. One very standard form of rectangular hyperbola is xy is equal to c square. Suppose I put c is equal to 1, I get xy is equal to 1, c is equal to 2. For every value of c, this is representing a hyperbola, and that too rectangular hyperbola. You can see actually there is no difference between this hyperbola and this hyperbola. Suppose I take this line x-axis, hold it from two sides and rotate it through 45 degree. What will happen? This line y is equal to x, when you rotate it to 45 degree, will come here and it will look like this. Let us see. Suppose this is the line y is equal to x, this is the line y is equal to minus x, and this is your hyperbola. Now I hold this line x-axis and rotate it to 45 degrees. What will happen? Every point, every line, everything will shift through 45 degrees towards its left. So this line will come here, this line will come here. Everything. I'm sorry. What happens? Let us first of all see. This line comes here. I'm just drawing the asymptotes now. Let me call it A, asymptote. Where has asymptote gone? Here. Since the other asymptote is perpendicular to this, and both of them are passing through this will be the next asymptote. Let me call it A2, A1 and A2. I'm just trying to see what happens to the asymptotes if we rotate through 45 degree in anti-clockwise direction. Now if the asymptotes are known, you can draw the hyperbola. It will touch here and here. Now simpler thing is, do not draw anything, but I draw just the asymptotes. That will be better understood. This is my one asymptote. This is second asymptote. My original hyperbola was like this, and this, if I just hold it and shift, it will become. So you can see in the slideshow that this hyperbola and this hyperbola are actually representing the same thing. There are certain things which we have not done, but you can imagine if we rotate axis through a particular line, every point rotates, and we can write the new position of a point. So if we rotate this axis through 45 degree in the anti-clockwise direction, we'll get this, and therefore This is a rectangular hyperbola. This is also a rectangular hyperbola. This is very should be clear. Oh, please, please. How we write equation xx minus 2yy plus 6x is clear, or it wants to say? Let me write down what the student is trying to ask online. It says x minus 2yy plus 6x plus 7y plus 9 equal to 0 in the form. Okay, xx. Okay, I'll just explain. Minus 2y1 plus 3x plus x1 plus 7 by 2. This is okay, this I told you in the last class also. Okay, whenever you want to write the equation of tangent to a hyperbola or ellipse or circle or any conic section including parabola, the technique is wherever you find x square, replace one of the x by x1. First write x square as x into x, then this. Wherever you find y square, write it as y into y, replace 1y by y1. Wherever you find anything like 2x, write it x plus x and replace one of them, one of the x1 by x1, and similarly to by one of the x's by x1. Similarly, y plus y can be written as. This is technique which tells you how to write the equation of a tangent. Suppose you are talking about this circle, x square plus y square is equal to 1. Tangent to this at the point x1 y1 will be x1 plus y1 plus 1 equal to 1. Equal to 1. Suppose I take x square plus y square plus 2x is equal to 0. Suppose this is the circle. How will write the tangent? x1 y1, but since it is 2x, it is to be written x plus x1 equal to 0. But suppose you have 3 here, x square plus y square plus 3x. So we will have to write x into x1 plus y into y1 plus, I want 2x separated. So 2x into 3 by 2. So this 2x is now written as 3 by 2 into x plus x1. The problem you have asked, since we had 7y here, we should write it as 7 by 2 into 2y, and this 2y is to be replaced by y plus y1. And if the point is given, x1 is 4, y1 is 3, we can replace the values of x1 and y1 by the appropriate numbers. And remember, this is true about all conic sections: ellipse, parabola, hyperbola, and circle. Anything else? Please explain the topic, Simple. Somebody online has asked to repeat what we mean by asymptotes. Actually, asymptote, if you are given a curve and the curve is such that it is coming closer and closer and closer to a particular line, then this line is called an asymptote. Remember, asymptote is always a line. Every curve does not have an asymptote. A circle has no asymptote. An ellipse has no asymptote. A parabola has no asymptote. But a hyperbola has an asymptote, because if you draw a line, it is meeting the line asymptotically. That means this line and this curve are coming closer and closer to each other. And for a hyperbola, since we are studying the standard form, asymptotes are written like this. And this is not the only curve which has asymptotes. When you write equal to 0, you get the equation of the two asymptotes. A curve may not have any asymptote, like this case, like this case, like this case. Circle, ellipse, and parabola have no asymptotes. A curve may have more than, may have exactly one asymptote. A curve may have more than one asymptotes, like a hyperbola has got two asymptotes, and their equations are known to us. For this case, x square minus y square equal to 1, I have told that it will have two asymptotes. One is x plus y is equal to 1, the other is x minus y is equal to 1. Similarly, there are other curves also which do have asymptotes. For example, if I don't know if you have carefully seen the graph of y is equal to ex. You know, e is a number greater than 2. You have seen this? You have studied the curve y is equal to ex. So, okay, let's take 2x. 2 raised to power x. How will the graph look like? If you try to find out values of y corresponding to x, suppose x is 0, y will be 2. X is 0, y will be 1. At 1, it will be 2. At 2, it will be 4. So values are increasing. It is going like this. But what happens on the left hand side? The graph will be something like this. Suppose I take x equal to minus 10. Y will become 2 raised to power minus 10. That means 1 upon 2 raised to power 10. This value will become very small. As you take, suppose x is equal to minus a big number, 6 zeros. 2 raised to power, how much is this? 1 million, 10 lakhs. 2 raised to power 10 lakhs in the denominator will be very small. But you will see that this function never has a negative value. You cannot find a value of x for which the value is negative. So what is happening? It is coming closer and closer and closer to 0. So the curve is like this. As you proceed on the negative side of x-axis, it comes closer and closer and closer to x-axis. And this distance you can see goes on decreasing. We say that this is an asymptote. This was general concept. But for a hyperbola, I have already told you how to find it. Asymptotes, they are two straight lines intersecting at the origin. For this, x square upon a square minus y square upon b is equal to 1, and so on. There's more question. Another question online is how to find product of length of perpendicular from hyperbola to the asymptotes. Oh, I explained it. We just did this question because you are given x square minus y square is equal to 8. What we do is we first write the asymptotes of this. Asymptotes are x square minus y square is equal to 0. That means x plus y is equal to 0 and x minus y is equal to 0. These are two asymptotes. Then take any point x1, y1 on the hyperbola. Because it is lying on the hyperbola, it will satisfy this equation. X1 square minus y1 square will be 8. Now, from this point, we have to draw perpendiculars. This is one line. What is the distance between x1, y1 and x plus y equal to 0? You have the formula. Replace x by x1, replace y by y1, divided by the coefficient of this, which is 1, squared up, coefficient of this, which is 1, squared up, it is x1 plus y1 upon root 2. Similarly, the distance of x1, y1 from x minus y equal to 0 will be x1 minus y1 divided by square root of 2. This is one perpendicular distance. This is another perpendicular distance. Multiply them, P1 into P2. When we write, it becomes x1 square minus y1 square upon 2. But x1 square minus y1 square, we have already seen it is equal to 8. So 8 by 2 is 4. Do you have any more question? Oh, derivation of somebody is asking how to derive the equation of asymptote from equation of hyperbola. That you need not do. That's I mean, you just need to know how the asymptote, what is the equation of the asymptote. We can derive that, but that is out of your scope. I think we stop here and we meet in the some other section for some other topic. Thank you very much for the patient listening.
Do we start again? Okay. So this is not an equilibrium. As you can see, the two sides, there is a lot of imbalance, right? So what I basically want to say is equilibrium in layman language means balance, right? The next one, please. So let us take an example. Say suppose we have two objects. One is a hot object, one is a cold object. Heat energy will flow from hot body to a cold body, right? Till when will this flow continue? Till the time when the temperatures of both the bodies become equal. So we will say that both the bodies have achieved the heat equilibrium. Both are in equilibrium with each other, right? So equilibrium is a dynamic process. Dynamism means there is a continuous movement. It is not a static process or stationary process, okay? Because whatever the product is being formed in the forward direction, it is continuously being used in the reverse reaction. For example, if we have any reaction A giving product B, right? So this is the forward reaction. A is continuously converting into B under some conditions, right? But at the same time, whatever product is being formed, it is converting back into A. Okay, this is what you call as dynamism in the reaction, right? So the equilibrium is a dynamic process where the product is continuously made in the forward reaction and at the same time it is at the same rate consumed in the reverse reaction. Is this clear? The next one, please. Okay, what is the symbol that you use? The most common mistake students make is they use this arrow. This is actually used for resonance. You must have used in organic chemistry where you show the flow of charges, right? So this is the arrow which you use for flow of charges, whereas this is the double-sided arrow which you use for showing an expression in equilibrium, right? Next one. Okay, let us take another example to see what is the basic criteria of equilibrium. Say suppose we have a decomposition reaction N2O4. It is a dimer. It is dissociating or decomposing into NO2, right? Both are gases. Now the difference, how you can make out, see both are gases. If you have N2O4 in a container, how will you come to know whether it is converting into NO2 or not? This is colorless and this is of brown color. So eventually when the brown color is going on increasing and increasing in the container, it means that the forward reaction is going on, right? But at one time the brown color will no longer intensify, it will become constant. So you will come to know that whatever N2O4 is converting into NO2, it is the same as the amount of NO2 which is converting into N2O4. So both are in equilibrium because the concentrations on both the sides of the arrows are equal. Is the concept clear? Okay. So the concentrations of all the species are constant at equilibrium because it is the point at which the rate of forward reaction will be equal to the rate of the reverse reaction. The next one, please. So if you have any arbitrary reaction A giving B, as I told you just now, this will be having a certain initial concentration. This will be 0 initially. Say suppose this is X amount. This will be initially 0. So what will happen? This concentration will go on decreasing. At the time t, this will go on increasing until the time that at equilibrium, the concentration on the reactant side will be equal to the concentration on the product side, right? Next one. So now coming to the first type of equilibrium, there can be several types of equilibriums. First, we will be discussing the simplest one which you see in everyday life, that is physical equilibrium. Say suppose you can take an example of ice-water equilibrium. Ice converting into water, that is H2O solid converting into H2O liquid, right? Similarly, you can have liquid and vapor equilibrium. Also, you can have iodine solid converting into iodine vapors, because iodine is highly volatile. If you have iodine granules at room temperature, they will slowly evaporate. They are volatile, they will convert into iodine vapors which are of brown color. Okay, so you can have this experiment. It is a very simple one. You just take iodine in a petri dish, cover it with a gas jar. You will see that iodine vapors will slowly be coming and filling the jar. Okay, and at one point the color will stop growing further. At that time you will know that jitna iodine solid hai, it is converting into iodine vapors. The next slide. Okay, now another important law which governs this equilibrium is the law of mass action. Do you know about this law? What does it state? Yes, actually, it is the ratio of concentrations of products to reactants. Okay, that ratio is always a constant, because at equilibrium, the concentrations will be at a constant state. So, and how is it different from equilibrium constant? In any reaction, if you are raising the concentration terms to the powers, what should be these powers? These should be the stoichiometric coefficients of the balanced chemical equation, right? First of all, you should have a balanced equation, then only you will be raising them to the stoichiometric terms, and that will be a expression of equilibrium constant. Okay, we'll take some examples. So let us say we have this arbitrary reaction A, that is A moles of A plus B moles of B, giving this as a product. So you will have equilibrium constant as concentration of the products P and Q raised to their powers of stoichiometry in the equation, divided by the concentrations of the reactant raised to their powers of stoichiometry, right? So Kc is known as the equilibrium constant, right? And no matter whatever is the starting composition of reactants and products, this ratio will be always achieved at equilibrium. You can start with x and 0, or you can start with x and y amount, but eventually what will happen at equilibrium? This ratio will always appear. Okay, if one is in more amount on one side of the reaction, it will go on decreasing and lead to that product which is present in less amount. If we are starting with more amount of B, that is on the right hand side, it will slowly be converted into A. Okay, and ultimately A and B will be in a fairly constant ratio at equilibrium. Is it clear? Next one. Please let me know if I'm going too fast. I'll slow down. Okay. Is it okay? The speed is okay? Okay. So equilibrium constant, let us see some more features. It is based on the concentrations, as you have already seen, concentrations of reactants and products at the time of equilibrium, not at any other time. Okay. The reaction will start at 0 minutes. Say suppose reaction is achieving equilibrium in 10 minutes. So the Kc expression which you will be writing, it will be at 10 minutes, not at the concentrations which are there at 8 minutes or 6 minutes. Is it clear? How? Why? Because see, if this is your initial setup, A giving you B. Say suppose this is at time t equal to 0. This is present in some amount, this is 0, right? Now at some any time t, this will have decreased by certain amount and this will have increased by certain amount. But what is their concentration at equilibrium? That is important to us, because this concentration will be appearing in the expression for equilibrium constant. Okay, so you will only have this at the equilibrium concentration. Okay, now till now what we have seen is the reactants and products were in all they were all in one phase. What will happen? say if they are in gaseous phase, अभी तक हमने ये decide नहीं किया था that whether they were in one phase or the other phase, right? Let us say if we have a gaseous reaction, in that case instead of Kc we represent it by Kp, which is denoting that the partial pressures of the terms are involved. Because they are gases, we will have to take their pressure instead of concentration, right? In case of gases you talk about pressure term rather than the concentration term. So Kp will be the equilibrium constant when they are gases, and these are the measures of partial pressures. Is this clear? Next. And what is the relation between Kc and Kp? Are you familiar with this? All of you? And how we arrive at this relation? We already know that from the ideal gas equation, PV is equal to nRT, or we can write pressure is equal to nRT by V. Number of moles divided by volume is nothing but the concentration term. Okay, this is the concentration term. So I can write pressure is equal to concentration into RT, right? So this is the Kp value for this particular reaction. Pressure of C, pressure of D divided by pressure of A, pressure of B raised to the stoichiometric terms. Now this I can write as concentration into RT, right? And if I club all the RT terms, I will get delta N, that is change in the number of moles of gas, only gas. Okay, it is actually delta Ng. Kp is equal to RT raised to the power delta Ng, where delta Ng is the change in the number of moles of gases on the product side minus the reactant side. Okay. Now we have some more examples to show the relationship between Kp and Kc. For example, this is the equation. Okay. So what will be the change in number of moles in this reaction? It will be 1 minus 2. Delta N will be 1 minus 2. So it becomes minus 1. So Kp is equal to Kc by RT, right? Say suppose we have this, both the reactant and product side are having 2 moles each of the gas. So delta N is equal to 0. So RT raised to the power 0 is 1. So Kp is equal to Kc. In this reaction also similarly, you can see the values of Kp and Kc, how they are related. So if you have to write down the reaction quotient, do you know what is the reaction quotient? And how is it different from equilibrium quotient or equilibrium constant? If you are, yes. No, that will depend upon the value of K and Q. But what is Q actually? If you are talking about the ratio of concentrations at any time T, okay, that is known as the reaction quotient Q. But only at equilibrium time T equilibrium, it will be known as Kc or Kp. Okay, so reaction quotient for any chemical reaction which is represented by Q, it is the same but the concentration will be different, right, at a time T. Just as I gave you an example just now, if a reaction is achieving equilibrium in 10 minutes, the concentration will be at 10 minutes, not at 6, 7 or 8 minutes. But if you have to write down the expression for Q, you can use that 6-minute expression also. Is it clear? So for this reaction, you will have NO2 raised to the power 2, that is the stoichiometry, divided by N2O4. Is this clear? Similarly, if you have ionization of sulfuric acid, it will be liberating 2 protons, right? So the reaction quotient will be H plus raised to the power 2 sulfate and divided by the concentration of sulfuric acid, right? Similarly, I have one more example. All the 3 reactions are the same, but there is a slight bit of change between three. This is why I have taken this example, to show how by slightly modifying the reaction quotient will change every time. For example, if you have the reaction for formation of water, 2H2 and O2 combining to give you water, this will be the reaction quotient, H2O raised to the power 2 and hydrogen raised to the power 2, because that is the stoichiometry. Huh? Okay. And if you look at this example, I have just taken it in a reverse manner. I have just reversed the reactant side and product side. Okay, so what is happening now? Whatever was in the numerator is going to the denominator in this case, and vice versa. So what will be the relation between the Q reversible and Q? It will be a reciprocal, right? Now, if I take another example, I have just multiplied the first reaction by 2. Okay. So now what will be the relation? Whatever was the stoichiometry in this case, it has been doubled. Is it clear? So when you have doubled the stoichiometry, you are getting this expression that is equal to square of Q, right? So if I am doubling the stoichiometry, the power is raised to 2. If I am reversing the reaction, the power is becoming minus 1. That is the reciprocal. Next slide. Okay. So these are the basic key points about equilibrium constant. It is the ratio of products to reactants always. Okay. Larger will be the value of K. The product side will be dominating, right? K is concentrations of products divided by concentrations of reactants. So more is the value of K, more will be the concentration of the products. That means, is this clear? And smaller the value of K, the reactants will be more and the products will be less, right? Reactant side will be dominating. So when K is very large as compared to 1, products will be dominating at equilibrium and it will be lying to the right, because the products are being formed in more amount, so equilibrium will be shifting towards the right. Whereas when K is less than 1, means the reactants are dominating at equilibrium, so the equilibrium will be shifting towards the left hand side or the reactant side. Is this clear to all of you? For example, if we have this reaction with us, again the decomposition of N2O4, what will be the Kc value? NO2 raised to the power 2 divided by N2O4. Now this value for this particular reaction, Kc is 0.212. Okay. Now if I just, no, next one. Now if I just approach the reaction from the opposite side, okay, equilibrium can be from the left side also and from the right side also, because it's a two-way process like this. A will be giving B, simultaneously B will be giving you A, right? So if this is the case, I have just reversed the reaction. What will be the Kc value now? N2O4 divided by this, that will become 1 upon 0.2. So it is exactly the reciprocal of the value which was that in the forward direction. Is it clear? Next. Okay. So till now, whatever we have discussed, it was all related to homogeneous phase, means all the gaseous components were there or all the aqueous part was there, means the reactant and product sides were in the same phase. Now, if we have reactants or products which are in different phases, one may be aqueous form, the other may be gaseous form, the other may be solid form, right? The phases might be different. So it will be known as heterogeneous equilibrium, right? For example, you can see the decomposition reaction of calcium carbonate. This is giving you calcium oxide, which is a solid, and it is giving you a gaseous product, CO2. So this is the setup. You have calcium carbonate and slowly carbon dioxide is being formed and the leftover part is calcium oxide in the pellet, right? So Whatever you have, nothing is in solution form. So can you determine the concentration? No. You can always determine the concentration if you have a solution, right? You cannot find out the concentration of something which is not a solution. You have to have a solution. Solution का ही concentration निकालते हैं ना हम, right? We therefore ignore the concentrations of pure solids and pure liquids in the equilibrium expression. We take them as equal to 1. Pure solid and pure liquid will always be equal to 1, and only the rest of the terms we will be taking in the expression for equilibrium. Let us take up an example. For this reaction, CO combining with H2 and giving you methane and water, the equilibrium mixture is having these many moles of the 4 components respectively. What will be the equilibrium constant for the reaction? I think it is very simple. You are given the number of moles, 0.07, 0.11, 0.03 and 0.03 is the number of moles. So Kc will be simply 0.03 multiplied by 0.03 divided by 0.07 and 0.11 cube, right? This will be the equilibrium constant. Next. Another example which is of the similar type. Say suppose you are having 0.1 moles and 0.2 moles of these two gases, and you have a 1 liter vessel at a temperature T. Now the mixture is found to have 0.03 moles of water at equilibrium, right? What is the equilibrium constant value? So basically this is the starting amount. You know that these two have 0 values. They are not there initially. At equilibrium, water is having a quantity of 0.03 moles. So what will be the change in all the components? This is decreasing by some x amount. This will be decreasing by 3x amount because the stoichiometry is 3. This will be increasing by an amount x, so it is plus x. This will be again increasing by an amount x, which we know it is 0.03. So at equilibrium, you will be having these amounts, 0.1 minus x, 0.2 minus 3x, 0.03 and 0.03. So simply you can substitute in the expression for Kc and you can calculate the value. Is this clear? Next. Let us take another example. Now you have 0.08 moles of carbon monoxide and 0.14 moles of hydrogen and 0.08 moles of methane. Okay. And the equilibrium has 0.01 moles of water for this reaction. What is the equilibrium constant? You know these three quantities initially. So initially water is 0, right? Now at equilibrium, that we know water is 0.01 moles. So we can decide how much is each quantity changing, right? 0.08 minus x, 0.014 minus 3x, and so on, just as we did in the last case. So we can simply substitute in the expression and we will be able to find out the Kc value. Is this clear? Why I did 3 examples of the same type? Because in all the 3 examples, one or the other quantity was mentioned at equilibrium. From that you can calculate the value of other number of moles of other quantities and you will get the value of Kc. Okay. Now another one, we have equilibrium for this following reaction. The 3 gases are introduced into a container at partial pressure of 3.6, 5.1 and 8 for the 3 gases. Okay. And the equilibrium pressure of NO2 is measured to be 2.4 atmosphere. Means you know that this is 2.4 atmosphere at equilibrium. Now you have to calculate the value of equilibrium constant for the reaction at this particular temperature, assuming that there are no other reactions taking place. Okay. So we know that the initial amount is 3.6, 5.1 and 8. for the three components, right? Whatever will be the change, we will be subtracting from the initial concentration, right? What will be the change? Say suppose x is the quantity which is mentioning the change. So this will be decreasing by 4x amount, this will be increasing by 2x, and this will be increasing by 3x, because we have to take the respective stoichiometry values also, right? So what will be the partial pressure at equilibrium? This we know NO2 is 2.4, right? So if this is 3.6 minus 4x is 2.4, which we know, can we calculate the value of x from here? Right? So once we have the value of x, we can just substitute in the other two terms, and we can also find out how much is the pressure of the other two gases at atmosphere at the equilibrium. Is it clear? This will be 5.1 plus 2x, 8 plus 3x. So simply substitute the value of x in the 2 and you will get the expression for K. K you already know, it will be partial pressure of N2O raised to the power 2, partial pressure of O2 raised to the power 3, and partial pressure of NO2 raised to the power 4. Is it clear? So just substitute the values and you will get the value of Kp. And can you tell me what will be the unit of Kp in this expression? It will be dimensionless. It is not concentration term, it is pressure term. So basically you have all the gases are having pressures in atmosphere, that is the unit of measurement. So this becomes atmosphere square, atmosphere cube, divide by atmosphere raised to the power 4. So the units will be, right, whatever value you will get, this will be the units. You know, sometimes in the MCQs you also get different choices where you might be having the same magnitude but the unit will be differing in the two choices, right? So please be careful about the units also. आप यहाँ पे k की वैल्यू तो कैलकुलेट कर लेंगे ठीक से सब्स्टिट्यूट करके, but you might not be able to, you might overlook the units, so you have to be careful about both the magnitude as well as the unit of the quantity. Okay, next. Okay, now I have some other unsolved problems also with me. I think you can try along with me. Suppose you have 1 mole of nitrogen which is mixed with 3 moles of hydrogen. This is the reaction giving ammonia in a 4-liter container. Now only 0.25% of N2 is being converted into ammonia. Okay. Now calculate the equilibrium constant and then what will be the Kc value for this reaction. That also you have to calculate. If I am just reducing all the quantities to half. Can you try this one? Anyone? So this is your reaction. So what is the reaction value at time t equal to 0? Have all of you copied the question? Please, can we have the question? Yeah. So you have, in a 4-liter container, you have 1 mole this at time t equal to 0, 3 moles of this. It means the number of moles of ammonia is 0 initially, right? And at equilibrium, at the T equilibrium time, what will be the amounts? No, it is 0.25%. So you have to first be careful about that factor of percent also. It will be 0.0025. Yes. So this is decreasing by an amount 1 minus 0.0025. What about this? This will be, and what about the ammonia value? These will be the respective concentrations at equilibrium, right? So now can you calculate the value of K? What will be the equilibrium constant? Since it is all in the terms of moles, it will be Kc value, right? Had it been the quantities were given in terms of pressure, we would have calculated for Kp, right? So it will be ammonia raised to the power 2. This will be the expression. So we can simply substitute, right? And I can give you the answer. I have solved it. What will be the units? That I think you can tell straight away by looking at the expression, right? And what else do we have to calculate? The Kc value for this reaction. It will be, how will this be related to Kc dash? Half, under root. Kc dash will be it will be under root of Kc. So if you have one quantity, you can simply take the square root of this and you will get the. Is this clear? Next. Okay. We have another question over here. 1 mole of nitrogen is mixed with 3 moles of PCl5 in a 100-liter container and heated to this temperature. You know the equilibrium pressure. The total pressure, you know, it is 2.05 atmosphere. Assuming that there is ideal behavior, calculate the degree of dissociation of PCl5 and the Kp of the reaction. This question was also asked in one of the previous years in IIT. So how will you proceed? What all quantities are you given? It is given that at T equal to 0, you have 1 mole of nitrogen, 3 moles of PCl5, right? What else? So these will be 0. Where is nitrogen in the reaction? It is not participating in the reaction, but it is present in the system, right? You have decomposition of PCl5, but what role will nitrogen play over here? Equilibrium pressure is given to you. The pressure will be due to all the terms, that is all the gases present over there. So there will be nitrogen also which will contribute to the total pressure at equilibrium. Is it clear? Don't get confused with this because nitrogen is nowhere there in the reaction. So you have to take that part into account also. Okay. So what will happen at equilibrium? What will be the amounts? Say it is changing by alpha amount. So this will be 3 into 1 minus alpha and this will be, this is 3 moles. So 3 alpha and 3 alpha, C alpha, you write it right, like. And we know C is 3 moles. So I am writing it as 3 alpha and 3 alpha. So now what will be the total number of gases? You will be having nitrogen plus PCl5 at equilibrium plus PCl3 plus Cl2. And what will be the number of moles? You have 1 mole of nitrogen. No, at equilibrium. This is not 3 moles, it is 3 minus 3 alpha moles. Clear? You are now measuring the equilibrium number of moles. N2 is not changing. You will still have 1 mole, right? So this becomes 1 plus 3 into 1 minus alpha plus 3 alpha plus 3 alpha. Okay, so you can calculate this. It will be 4 plus 3 alpha moles at equilibrium. And you know what is the pressure at equilibrium, right? PV is equal to nRT because it is given that it is following ideal behavior, right? So you know the value of this, you know the total pressure at equilibrium. We can relate this, right? We know the volume of the vessels, we know the temperature. So we can simply substitute. We will get the value of N. Fine. And once you have the value of N with you, you can have this N is equal to 4 plus 3 alpha, right? So you will get the value of alpha. Now you have to tell what is the degree of dissociation. So simply 3 minus 3 alpha will give you the value of degree of dissociation of PCl5. Is it clear? Sure. Next. Okay. The equilibrium constant of this reaction is given at a temperature of 100 degree. Now if a flask is having 1 mole A2 and it is connected to another flask of 2 liters having 2 moles of B2, what is the amount of AB formed at this temperature 373? How will you proceed? I think this is concentration. Okay. Anyone else? At T equal to 0, you have 1 mole of this and you have 2 moles of this. This is 0, right? At equilibrium time, say suppose this is decreasing by X amount. This will be also decreasing by X amount. The formation of this will be 2X. Sorry? No. No, why? See, we are straight away finding out in terms of number of moles. This is in 1 mole, this is 2 mole, this is no 0 moles at initial point. And at the equilibrium time, say this is decreasing by an amount X. This is also decreasing by the same amount because the stoichiometry is 1 and 1. And the formation of AB is twice the amount of what A and B are dissociating. Okay, so this will become 2x amount, right? And what is the equilibrium constant? It is 50. So Kc will be equal to, this will be the relation. Stoichiometry is 2, right? So this is equal to 50. You can calculate the value of x from here. Fine. What do we have to calculate? What is the amount of AB formed? So simply 2x will be the amount of AB formed in number of moles. Easy? Next. So you are given that for this reaction, the Kc value is 16. If we have 1 mole of all the gases in a 1 liter flask, now see, the question is different from all what we have discussed till now. You have 1 mole of all the gases. Till now, we only had the reactants. The products at initial time were 0. So now you have a different question over here. Okay, what will be the equilibrium concentrations? Now you have to calculate what is the concentration of NO and NO2 at equilibrium. So how will you proceed? What will you do? Yes, at T equal to 0, all of them are 1 mole. At equilibrium time, T equilibrium, this will be 1 minus x, 1 minus x, and 1 plus x moles, right? So simply Kc or 16 is equal to 1 plus x by 1 minus x, right? You can solve it and find out the value of x. So what will be the equilibrium concentration of NO and NO2? Once you have the value of x, you can find out what is 1 plus x and 1 minus x. This is what you have to do, right? Next question. Okay, what about this one? You know that the Kp value is 900 atmosphere inverse. Okay, a mixture is having SO3 and O2. It is having a partial pressure initially of 1 atmosphere and 2 atmosphere. It is heated to a constant volume to allow equilibrium. Calculate the partial pressure of each gas at 800 Kelvin. How will you proceed? You have 2 SO2 plus O2, right? So initially you have 1 atmosphere and 2 atmosphere of and O2. This will be 0. It means the reaction is proceeding from the left to from the right to the left. Okay, so again this example is different from what you have done till now. This is 0 whereas the other two are present, right? Now can you tell me what will happen at equilibrium time? Okay, this will be 2x. Okay, 1 minus 2x or 2 into 1 minus x? What will be this? Then the next step is very simple. You simply have to substitute. So you have 2x and this will be 2 plus, not 2 minus x, because as I said, the reaction is going from this side to this side. So now you will have the minus terms on the right hand side and plus terms on the left hand side. Okay, it is just the opposite reaction. So this will be 2 plus x and this one will be 1 minus 2x. Is it clear? Next, what do? We simply substitute it. So 1 minus 2x square, 2x square, 2 plus x. You will get the value of x from here. Calculate the partial pressure of each gas. So simply when you have this value, you will have the value of partial pressures. Is it clear? Next one. Okay. At 70 degrees Celsius and 1 atmosphere, N2O4 is 66% dissociated to NO2. So what will be the reaction? N2O4 is dissociating into, and there is 66% dissociation. So what volume will 10 gram of N2O4 occupy under such condition? See, you have to calculate the volume and you are given grams. So it is better if you convert everything in number of moles. Okay, it will be easier and there will be less chances of making mistakes. That is why I selected this problem particularly, because you have to be careful about the units. Okay, so we will convert N2O4 into number of moles. How will you do that? Number of moles is given mass upon molecular mass. So you have 10 grams and the molecular mass, I'll tell you, for N2O4 it is 92 gram per mole. Okay, so you will have this divided by 92 moles, 10 divided by 92 number of moles. Fine. Now this is what will be their concentration at T equal to 0. At T equal to 0, you will be having 10 by 92 moles of N2O4 and 0 for NO2. And what will happen at equilibrium? 10 by 92, 66% dissociation, minus 66% of this. So I can write it as 10 by 92 into 1 minus. Is this clear? So 1 minus 0.66. And how much of this will be formed? 2 into 0.66 क्या है? 0.66 of 10 by 92 है ना? So don't miss this fraction. ठीक है? So this will be the amount at equilibrium for NO2, right? Now what is given to you? 66% dissociation. What volume will it occupy under this condition? Now basically आपको volume calculate करना है. How will you calculate? Pressure is known, temperature is known, number of moles you know. PV is equal to nRT or V is equal to nRT by P. Number of moles क्या होगा? 10 by 92 into what will be the number of moles? You have an equilibrium mixture with you. What will be the number of moles? It will be, no, it will be number of moles of this plus number of moles of this. Total number of moles at equilibrium क्या होंगे? You will have product as well as reactant, right? Reactant as well as product आपके पास होगा तो number of moles क्या होने चाहिए दोनों के? 10 by 92.66 plus ठीक है? So this will become how much? I can write it like this. Fine. So this will be the number of moles, 10 by 92 into 1.66. Number of moles, I've just taken it common and then clubbed the 0.66 factor, right? So this will be the number of moles multiplied by what is the temperature given to you? What was the temperature? 70 degree. So it becomes 343. What about R value? What will be the value that you will use? Pressure is 1 atmosphere, 0. Yes. So you will be able to calculate the volume. Sure? Next one. I think we'll discuss one more problem only, and we'll keep the rest for the end so that we can cover all the topics at least. So a sample of air is having N2 and O2. It is heated to 2500 Kelvin until the equilibrium is established. You are given the value of Kc. At equilibrium, the mole percentage of NO is given to you. Okay, and estimate the initial composition of air in terms of mole fractions. How will you proceed? The reaction is given to you. Mole percentage of NO at equilibrium is 1.8 at equilibrium. So how much will be the amount of mole percentage of this? 100 minus. So this becomes 98.2. Fine. So this is the mole percentage. Now what else is given to you? Say suppose we do not know what is the amount of NO2 and N2 and what is the amount of O2. We will take 1 as X. So let the amount of nitrogen is equal to X. What will be the amount of oxygen? Yes, 98.2 minus X. This will be the amount. Now what else? So Kc value is given to you. Kc is 2.1 into 10 to power minus 3. What will be the Kc from the expression? This will be the expression, right? And we know that this is 1.8. This is 98.2 minus X and X. So we know what is Kc. We can calculate the value of X from here. Fine. Now what do we have to calculate? Can we get back to the question? We have to calculate the initial composition of the air. We know the equilibrium values. From that we have to go back to the T equal to 0 value. Okay. So what will you do for that? We know what is the value now at equilibrium. How will you calculate the initial values? Anyone? Yes, very good. We will add X amount in the left hand side because initially that was present in that much amount. Now it is decomposing to equilibrium. So whatever we have minus X and minus X, okay, we are simply going to add it back. ठीक है, हम हर बार सब्ट्रैक्ट करते हैं ना t इक्वल टू 0 में से x अमाउंट. अब हमारे पास इक्विलिब्रियम पे वैल्यू है, हमें 0 पे निकालनी है. So we will simply add that value. Okay, so what will be the amount of nitrogen? It was X. I'll tell you the answer. It is 78.56 moles. So this will be plus, what will you add? Not 1.8, 0.9, because this is dissociating 1 mole giving you 2 moles. So 1.8 is formed means it was initially 0.9, 0.90, and then you had 1.8 moles. Is it clear? So this will be 78.56 plus 0.9. Similarly, what will be O2? O2 was 98.2 minus X plus 0.9. Okay, and then you have to calculate mole fraction. How will you calculate the mole fractions? You have number of moles of each. Just divide by total number of moles, you will get the mole fraction. Okay, next one. So basically, through all these examples, we have also covered some applications of equilibrium constant. How? Because in all these examples we have seen certain reactions which are occurring at equilibrium. Okay, so one application which you have seen in all these numericals which we have solved is predicting the direction of the reaction, whether the reaction will go to the forward direction or will it go to the reverse direction. Okay, so this is the reaction quotient for any arbitrary reaction. So K will be equal to Q only at equilibrium value. Okay, next one. I think we'll discuss the problems later if we have more time. Next, next, next. Yes. So last slide. So this is another application of equilibrium constant, calculating the extent of the reaction. How much extent is the reaction undergoing into the forward or reverse direction? The magnitude of the equilibrium constant will tell us the extent of reaction. Say suppose the K value is very large. It means that the reaction is almost complete and it is having mostly products. Okay, so it will be mostly products. But if the value of K is very small, it means the reaction will be having mostly reactants, right? And when it is around 1, means a significant amount of reactants and products are still present in the equilibrium mixture. Why K equal to 1 will mean this? Because it is ratio of concentration. So अगर ratio 1 आ रहा है means concentration of reactant and product are almost equal. Okay, next. So again, whatever we discussed, so if reaction quotient is greater than K, means that the reverse reaction will be occurring. Okay, reaction will go to left. And if Q is less than K, means that the forward reaction will be occurring. Next. Okay, another important parameter which is used to determine many other properties in thermodynamics. You must have studied thermodynamics also. What are the important properties that you calculate in thermodynamics? Gibbs free energy. What else? No. Ionization energy does not come under thermodynamics. You have entropy, enthalpy, then Helmholtz free energy. Randomness is entropy, S. What else? Enthalpy is H, right? And what else? Gibbs free energy is G. Helmholtz free energy is A. Have you studied thermodynamics? A is equal to E minus Ts. No? Okay, doesn't matter. So basically what I was saying is you can calculate, you can relate energy with the equilibrium constant. Okay, Gibbs free energy, are you all familiar with what is Gibbs free energy? No? Okay. What is thermodynamics there in your syllabus? Okay, have you studied it till now? Have you studied thermodynamics? Okay, some of you have studied or some of you have not studied. Doesn't matter. So basically, then I'll just explain it to you. For any reaction A giving products, okay, whatever is the free energy of a reaction means whether the reaction is occurring or not, spontaneously or not. Spontaneity मालूम है आपको क्या होती है? A reaction is spontaneous, means the reaction is occurring on its own. It is having a certain energy so that it will undergo completion. But some reactions are not spontaneous, they will not occur on their own. Okay, they will not be having a particular energy so that they can give products. Okay, that free energy is essential for a reaction to occur. So free energy is denoted by this G, Gibbs free energy or Gibbs free energy. Okay, so for a spontaneous reaction, we have a negative value. Okay, and delta G is, it can be related with equilibrium constant through this expression. I think you will be appreciating it more if when once you have studied thermodynamics. Okay, again, I think this topic will be coming in the applications of thermodynamics where you can relate K and delta G. So I think we can skip it for now. Okay. Le-Chatelier's principle, I think all of you must be familiar with this. So basically this is one very important principle of thermodynamics. Oh, sorry, of equilibrium. That means if you disturb any reaction, it will go in that direction so that whatever change you had brought about, it will undo or reverse that change. Okay, so if you disturb an equilibrium, it will shift in such a direction, it will undo the disturbance. Okay, in a system at equilibrium, the concentrations will always arrange themselves to get the value of K equilibrium. That is, the K equilibrium, as I discussed earlier also, it will be the same throughout at equilibrium. Even if the reaction is at equilibrium and you disturb it, okay, again the changes will take place in the reactant and product side to get back to equilibrium. Say suppose, let's take an example. A is in equilibrium with B, reactants and products. Okay, now say what will be the Kc value here? Okay, this reaction is at equilibrium. If I increase the amount of B, what will happen? If I increase this, reaction will go more in this direction. This is an excess, obviously this won't be formed. So B will start converting into A. Okay, so as a result, if I increase this, K value will increase. But now A is going to start increasing. So if A starts increasing, what will happen to the K value? It will again start decreasing and come back to the original value. So whatever change you are bringing about, the equilibrium will re-establish. Okay. For example, I'll give you a very layman type of example for this, which is not at all related to chemistry. Say suppose you have a vessel like this. Okay. You take a ball, you put it in the vessel. Where will it move? It will always come down to the base. If I take the ball over here, again I leave it, it will come back over here. If I take it here or here, at any point, it will automatically come back to this place, right? Because this is the most stable position for the ball, right? Similarly, any reaction will eventually come back to the equilibrium position, whatever disturbance you bring. It will eventually come back to the equilibrium because that is the most stable state. Okay, is it more clear with the help of an example? Next. So, if you add any reactant or product, equilibrium will shift away from that increase. As I told you just now, if you are increasing the amount of B, the equilibrium will shift away from the increase of B, right? If you remove any reactant or product, equilibrium will shift towards the decrease. Okay, if I am adding one quantity, it will shift to that quantity which was less. If I remove one quantity, it will shift to that quantity again so that the equilibrium is re-established. Is the concept clear? Okay. So basically, let's take an example of Haber's process. You must have studied Haber's process of ammonia synthesis. पढ़ा हुआ है? Okay, next slide. So we are going to take this reaction. This is used for preparation of ammonia in the industry, right? It is a very common industrial process. So what we do is, if we add hydrogen, what will happen? If I have more of hydrogen, it will automatically combine with nitrogen and give you ammonia. So if I am increasing the reactant, it is combining and giving you the product. So the according to the Leach-Ateliers principle, equilibrium is shifting towards the lesser side to undo the change which you have brought in hydrogen. Is it clear? So to counteract the added hydrogen, the reaction is shifted to the ammonia side. So more of ammonia will be formed, right? Now, next one. Okay. So I think the same thing has been explained over here also. If I am going to increase or decrease the pressure or volume of one quantity, the equilibrium will accordingly shift so that that change is compensated. Is it clear? Next. Next. Now, how does the temperature affect equilibrium? Anyone? Can you explain the reason? Okay. Okay. See, I'll give you a very simple way. You will not have to remember कि क्या हो रहा है, किस डायरेक्शन में, किस केस में कहाँ पे रिएक्शन मूव करेगा. Since it is a reaction involving heat, what we'll do is we'll take heat as one of the reactants. Just as we have been studying reactants and products on both the sides of the arrow, we will take the heat component also as one of the reactants. So if you are adding heat, means you are having more amount of reactant, the reaction will automatically go to the product side, right? So equilibrium will be shifted away from that increase, that is towards the product side, right? And then accordingly you can work out the reaction for exothermic and endothermic. Just that you can consider heat as one of the components or constituents of the reaction. Then there will be no need to remember for exothermic, endothermic, any case. Okay, next. So I think the same thing has been explained with the help of an example. Chromium complex with water with chlorine ions, it gives this complex. Okay, now this has delta H greater than 0. So this reaction can be monitored with temperature because this compound which will be formed is pale pink and the original one, the product is blue colored. So whether there is a change in the color of the reaction from pink to blue and vice versa, it can be monitored by increasing and decreasing the heat. Okay, next. Okay, so till now what we have discussed is all physical and chemical equilibrium. We saw the physical equilibrium in the initial few slides, that is when solid liquid or liquid vapor or solid vapor equilibrium was established, that is between the physical states of matter, right? Now we come to another aspect of equilibrium, that is ionic equilibrium, and that will be when the equilibrium is established between the ionic species, means the reactant or product side will also be having certain ions. Okay, so basically we should be knowing some terms before going to the actual explanation. What are electrolytes? Yes, the electrolytes are those which when dissolved in aqueous form or in water, they will dissociate to give you ions. Okay. Now they can give you either cations or anions. If they are salts, they will give you both cations and anions. So electrolytes on dissolution, either they can ionize completely. In such a case, they will be known as strong electrolytes. And if they are not dissolving completely, they will be known as weak electrolytes. Example, you must be doing titrations. करते हैं आप titrations lab में? आपने कौन सी titration करी है? HCl NaOH you must have done. Okay, so when you make a solution, HCl is completely dissolved in water, right? It will completely give you H plus and Cl minus ions. Similarly, NaOH, when you dissolve, or let us take a very simple example, not in the chemistry lab, but at home, NaCl, common salt which you eat, you dissolve 1 spoon of salt in glass, it will dissolve completely. But what is the chemistry behind that? You know that salt has dissolved, but actually it has dissociated into Na plus and Cl minus. So such electrolytes which dissolve completely or dissociate completely are known as strong electrolytes, and those which do not dissociate completely are known as weak electrolytes. One very common example is acetic acid. Okay. Next. Then we come to the concept of acids and bases. What are acids? They will furnish H plus ions in solution, whereas bases will furnish OH minus or hydroxyl ion in solution. But that is one concept. Okay, Arrhenius concept says that H plus will be, or H3O plus will be furnished by acid, and OH minus will be furnished by base. But there are also several other models which gave the concept of acids and bases. One was given by the scientists Bronsted and Lowry, and they said that acid will be a proton donor and base will be a proton acceptor. So they did not talk in terms of H plus and OH minus. They only talked in terms of proton. Whatever is accepting a proton, it will be a base. Whatever is donating, it will be a acid. And there is another concept given by Lewis acid bases. Lewis acid base theory says that whatever species is electron deficient in nature, if something is electron deficient, it will have a tendency to accept electrons. So electron deficient species will always be acting as a acceptor. Example, B BF3 is electron deficient, AlCl3 is also electron deficient species. Whereas if a species is electron rich, there will be more electrons, it will be acting as a electron donor. For example, all the species which are having lone pair, for example ammonia, okay, so they will be acting as donors, so they will be Lewis bases. Is it clear? Next slide. So this is the concept of conjugate acid-base pairs. So if you have anything which can gain proton, it will be a base. And anything which can lose proton, it will be acting as acid. So in this reaction of ammonia and water, ammonia is acting as base, water is acting as acid. Next one. Let us take another example of acetic acid and water. Here, acetic acid is liberating H plus and converting into acetate ions, right? So, since H plus is being generated, it is a source of H plus. It will act as, it is a H plus donor, so it will act as acid. Okay, whereas this is gaining H plus and forming this, so it is a base. Okay, so next slide. Okay, Okay. Okay, and what about the rest of the slides? Ionic equilibrium. Okay, fine. What is the pH? Okay, this is also ionic equilibrium. Yes, because pH I was about to discuss in the ionic equilibrium topic. Iodine will sublime into vapor state. Why is it shown aqueous? It was vapor state. In calculating the equilibrium constant, should we consider the concentration of the precipitate? No, because whatever precipitate will be formed, it will always be a pure solid. So we will not be considering the concentration. Next question. Problem 9. Okay, can we go back to the presentation for problem 9? Okay, so equilibrium constant Kp of the reaction is given to you. SO2 plus O2 is giving SO3 is 900 atmospheres, Kp value at 800 Kelvin. Okay, a mixture has SO3 and O2, and mixture is containing SO3 and O2, and the initial pressure is 1 atmosphere and 2 atmosphere. Okay, and it is heated at a constant volume. In order to allow equilibrium, calculate the partial pressure of each gas at 800 Kelvin. So I will repeat as we did earlier. Since in all the other examples we had this plus this giving products, so initial concentration of reactants was given to us, product was taken as 0 initially, but then at equilibrium we had certain values. In this question, the opposite data is given to us, that product is having a certain concentration, one of the components is having a certain concentration, then we are allowing equilibrium to establish. So what will happen? This will be 0 initially. So at T equilibrium, this is at time T equal to 0, this is the composition. Fine. Now at equilibrium, what will be the amount? This will be decreasing by an amount 2x, right? This will be increasing by some amount x, so the change will be 2 atmosphere plus x, whereas this will be 2 into x. This will be the concentration at equilibrium. Now what we'll do next? Kp is 900 atmosphere inverse. What will be the relation? SO3, I think I'll write in terms of partial pressure because pressure terms are given. pressure of SO3 square, pressure of O2, pressure of SO2 square. So 900 is equal to this. So 1 minus 2x square, O2 is 2 plus x, and this is 2x square. So from this we will get the value of x. I will give you the value. It is coming out to be, sorry, it is not, this much is the value of x. Okay, now what we have to do is we have to calculate the partial pressure of each gas at 800 Kelvin. What will be the partial pressure? Partial pressure of this gas is 1 minus 2x. SO3 is 1 minus 2x. Partial pressure of O2 is 2 plus x. Partial pressure of SO2 is 2x at equilibrium. This is what we have to calculate. X we have already calculated. Simply substitute in all the three. You will get the value of the partial pressures. Is it clear? Next question. Explain problem 11. Okay. What was problem 11? Can we go back to that? So you have a sample of air having N2 and O2, giving you 2 moles of NO. Kc value is given to you. Mole percent of NO is 1.8. Estimate the initial composition of air. Means we have to calculate what is the initial value at time t equal to 0 for N2 and O2. We have the equilibrium value with us. Okay. So what we do is we can say that since this is the reaction and at equilibrium this is 1.8. Okay. So what will be this amount? 100 minus 1.8, which is 98.2 moles. Fine. So we can take one as x, the other one will be accordingly 98.2 minus x, right? So let us assume x is the amount of N2 in this mixture. So amount of O2 will be this much. So now we know that in this reaction of N2 plus O2 giving 2NO, this is x, this is 98.2 minus x, and this is 1.8. Kc value is given to us. We will simply substitute in the expression. Kc is equal to 2.1 into 10 to the power minus 3, and it will be equal to this. So simply this is equal to NO raised to the power 2, N2 is x, and this is 98.2 minus x. You can calculate the value of x from here, right? So I'll give you the answer also. X is coming out to be Now the last step was important. I think there must have been a doubt in that. We had to calculate the initial values of N2 and O2, right? Normally what we do is we have A plus B giving C. We have say A amount and B amount. This is 0. Then we have this. Now this is already known to us. We have to get back to step 1. That is at time t equal to 0. So what we will do is, if we add this amount, the amount which had changed, we add it to the initial, the value at equilibrium, we will get the initial value, right? So simply what we do is, the mole fraction or amount of N2 will be, what was the amount? It was X, that is 78.56, plus, since 1.8 was the mole percentage of the product, we will have to add how much? 1.8 by 2. Okay, because N2 plus O2 is giving you 2NO. So X and X is going to give you this, right? This is the change. This is decreasing by X amount. This is decreasing by X amount. This is increasing by 2X amount. So here 2X is 1.8. So you have to divide by half. Is this clear? Right? So again, this will be 78.5, sorry, 98.2 minus X plus zero point 0.9. This will be the result. Okay. Next question. Okay, we can go back to problem number 7. Okay. So we have A2 plus B2 giving us 2AB. All our gases. So you have a 1 liter flask which is having 1 mole of A2, and you have a 2 liter flask which is having 2 moles of B2. What is the amount of AB being formed? Okay. So you know that at T equal to 0, this is the composition: 1 liter flask of A2, 2 liter flask having 2 moles. Okay. Now what will happen at equilibrium? This will be decreasing by an amount X. This will be decreasing by an amount X. This will be increasing by an amount 2X, right? So this is increasing and the other two are decreasing. Fine. So now what will be the Kp value? It is given to you, it is 50. It will be 2x raised to the power 2. I'll write the complete expression. AB concentration, A2, B2. So this is square 1 minus x, 2 minus x. I'll write down the answer also. X is coming out to be 0.93 moles. Okay, and what do we have to calculate? We have to calculate the amount of AB which is being formed. So what will be the amount of AB being formed? It is 2x. We already have the value of x. So the number of moles of AB will be simply fine. Next question. That's it. Any other questions from your side? Any doubts? No? we will not need it. It is just to create a confusion. Okay. See, you have the values of number of moles with you. Had it been some other quantity, okay, mole percentage or mole fraction, then you would have to consider that. But since you have moles, that is why I said the most convenient method is that you should convert all the terms in number of moles. I think we had solved one numerical where I told you to calculate in the mole percentage into moles, because then it is the best method where you can avoid all I think errors due to this conversion factor and all units. Okay. Why iodine on sublimation? No, this is a typing error. As I already mentioned, iodine on sublimation will be giving iodine vapors. It is not aqueous, it is vapor. Okay. Any doubts from your side? Okay. Yeah, we can discuss those problems which we had left. Okay. We had discussed till 11. Okay. So here we have 1 mole of H2 and 1 mole of I2. They are introduced into a 5-liter scaled flask. The mixture is heated to a certain temperature and the following reaction is taking place. H2 plus I2 giving you HI. At equilibrium, there is 1.58 moles of HI. Okay. What are the concentrations of these at equilibrium? And also find out the equilibrium constant. How will you proceed? At equilibrium, you have 1.58 moles of HI. Means at T equal to 0, this is there. At T equilibrium, the equilibrium time, this is there. Okay. Can you go to the next slide? Yes. So this is decreasing by this much amount, right? And on the product side, you have this increase by this much amount, right? So simply put in the formula for Kc, and this will be stoichiometry will be there, Hi raised to the power 2. Simply substitute the values of concentrations, you will get the value of Kc. Fine. Next one. Okay. zero point 0.5 moles of HI are introduced into a 1-liter flask and heated, and equilibrium mixture shows that 0.105 moles of HI have decomposed. Calculate the equilibrium concentrations and equilibrium value, constant value. Again, how will you proceed? Now you have 0.5 moles of HI initially, okay, and it is decomposing to give you H2 plus I2, right? And at equilibrium, 0.105 moles have decomposed. Means how many moles are left? This much, right? These many moles have decomposed. So at equilibrium, you are left with these many moles of HI, right? Can you calculate the concentrations of other terms? Next slide. So this is there. Initially, this is 0, only 0.5 moles of this, right? And then 0.105 moles are decomposing. So we have 0.5 minus point this becomes 0.395, right? And this is increasing by how much amount? Yes, it will be, the ratio will be, this is 2 HI on the right hand side. So you will have 0.105 divided by 2 over here in both the terms, right? So this will be 0.105 by 2 and this also 0.105 by 2. As you can see over here, 0.0525. Simply put in the terms for the uh, Kc expression and you will get the answer. Is it clear? So you have to first be careful in any problem, any numerical of equilibrium, you should first write down the reaction, write down the initial values, and if any equilibrium data is given to you, so basically this is the approach. Write down the initial value, what is the change taking place in that value, and then what is the equilibrium value if any of the reactant or product side is given to you. I think you will never make a mistake if you go step by step. Okay, and then once one concentration is known, you can add or subtract depending upon the reactant and product side, and you will get the value of Kc accordingly. Is it clear? Next. Okay, so now this is the reaction, and you have 1 atmosphere of N2O4 and 2 atmosphere of NO2. Okay, you are allowing equilibrium. When the equilibrium is established, partial pressure of NO2 has decreased by 1.24 atmosphere. So now you have to calculate the partial pressures at equilibrium and the Kp-Kc value. How will you proceed? At equilibrium, the partial pressure of NO2 has decreased by 1.24 atmosphere. So whatever is the decrease, 2 minus, no, it has decreased, yes, it has decreased by this amount. Yes, okay, so it will be this. And what about this? Any stoichiometry? Where? Where will the factor come or will it not come? Where will it come? Don't be confused by the value that is given. Okay, simply if this is 2 atmosphere, this is 1 atmosphere, it will be decreasing by say an amount x, and this will be increasing by amount x by 2. Okay, so now you can just work out in terms of the atmospheric pressure that is given to you, right? And then you have to calculate Kp and Kc. Since it is given in terms of pressures, we will calculate Kp value, right? And then, so it will be partial pressure of N2O4 divided by partial pressure of NO2 square. And Kp is equal to delta Ng. What will be delta Ng for this reaction? 1 minus 2, right? So RT to the power minus 1 or simply Kc by RT. So if you have the value of Kp, you know R and T. Okay, temperature is also given 25, so it is 298 Kelvin. You can calculate the value of. Is it clear? Next. Methanol is produced according to this following equation. Okay. So in an experiment, 1 mole of CO and 1 mole of H2 are allowed to react in a sealed container. When the equilibrium is established, the mixture has 0.0892 mole of methanol. Okay. So this is at T equal to 0, and at equilibrium, this is the value which you have, right? When equilibrium is established, this is the concentration of methanol. What are the equilibrium concentrations of all the three species? So firstly, you have to calculate what is the equilibrium concentration. You already have it in terms of number of moles. So you will express it in number of moles, and also calculate the equilibrium constants Kp and Kc. So how will you proceed? This will be decreasing by 1 minus x, 1 minus 2x, and this will be x. So x you know, right? You can calculate this as well as this in terms of number of moles. Now you have to calculate Kp and Kc. So you have to express either in terms of pressures or in terms of concentrations, right? Because this will be involving pressure terms. Kc will be involving concentration terms, and you have all these in terms of number of moles. How will you convert it? Number of moles you are given. Can you convert it into concentration? See, if you have to convert into molarity. Molarity is number of moles per unit volume, right? You have the number of moles with you, and you also have the volume of the container, right? It is a 10-liter flask. So you can simply convert all the three components into molarity terms, and then you can calculate Kc, right? Because you will have molarity with you, and Kp is equal to Kc RT raised to the power, what will be delta N? 1. Okay, minus 3 is minus 2, right? So once you have one quantity, you can always calculate the other quantity. Is it clear? We have divided by volume because we had to calculate Kp and Kc. In that question, Kp or Kc value was given to you, right? Here we have to calculate, and in the formula of Kp and Kc, what do we need? Either pressure or concentration. And what are we solving the numerical in? In terms of number of moles. So we have to convert number of moles into molarity. Okay. This is again a doubt. When Hi decomposes to H2 and I2, why Hi concentration will be written in numerator? See, the numerator and denominator will depend upon what are the reactants and products, right? If you have Hi on the product side, it will come in the numerator. If Hi is on the reactant side, it is decomposing, it will come in the denominator. Time is up. Thank you.